Hey guys, today we are going to be looking at lesson 4, which is about proportional relationships. You should be in volume 1 of your book. This is unit 1, lesson 4, and it starts on page 33. However, I skipped over the first page because it's just an example, and I went straight to page 34 where it tells you what a proportional relationship is. And as you can see in the book, it just says that two quantities are proportional if they have a constant ratio or unit rate, which basically just means that if your ratio, aka fraction, can be reduced to the same number, then it is proportional. If your fractions cannot be reduced to the same fraction or the same number, then it is not proportional. And then there's an example about the cost of pizzas. So $8 is how much it costs for one pizza, $16 for two pizzas, $24 for three pizzas, and you can see it goes down the line. However, all of those fractions or ratios can be reduced to $8 per pizza. And then it just says that the ratios are equivalent. And again, they're equivalent because they all reduce down to the same thing. Now in your book, there's 4 examples that are already worked out for you. I'm not going to go over those ones because you guys can look at them yourselves if you want some help with those. But what I do want you to jump to is to page 36, where it has the guided practice problems. Now I'm going to warn you guys, my pen is not working, so I am typing all of this on my computer. So hopefully it does not get too messed up. So problem number 1 under the guided problems says the Vista Marina rents boats for $25 per hour. In addition to the rental fee, there is a $12 charge for fuel. Use a table to determine the number of hours you rent the boat to see if it is proportional to the cost. All right, so let's start with this. Rental time in hours. Well, most people rent boats initially for 1 hour. So we're going to start with that. And we want to see what the total cost would be. If I rent my boat for 1 hour, I know that it is going to cost me $25 because that's my hourly fee. And I know I also will need to pay $12, and that is my fuel fee. So altogether, how much does it cost for 1 hour? This is me pausing so you can tell me the answer, guys. Good, $37. I'm hoping you all said this at home in your house. All right, so for my table right here where it says cost, I'm going to put $37. And now I'm going to go on to 2 hours. So I know that I will have a $25 hourly fee. I know I'm going to have another $25 hourly fee because it's for 2 hours, so I need 2 of them. And I know that I also have a $12 fuel fee. And 25 plus 25 plus 12 should give me $62. Oh man, my box. All right, so in my table, I will have 2 hours. I can spell hours. And in my cost, I am going to put 62. And then we'll do it for one more 3 hours. So I'm going to have my $25 hourly fee. I'm not going to keep writing that because you guys know what that is by now. And I have my $12 fuel fee. So for 3 hours, I have 25 plus 25 plus 25 plus 12. And if you add all of that up, you should get $87. So in my chart, I will have 3 hours. Apparently I made my font too big, and this will be 87. Hopefully all of that is making sense so far. And then it says to determine whether or not the number of hours we rent the boat is proportional to the total cost. So essentially what we're trying to do is see if all of these fractions reduce down to the same thing. So if we look at The first one, I'm going to put this over here and I'm going to make this in red. We know that the ratio or the fraction would be 37, because money is always number one, it goes on top, for every 1 hour. Now for 2 hours, my ratio, again, I'm pulling it from the chart, is $62 over 2 hours. And because I can simplify this, remember, we're going to use our unit rate, numerator divided by denominator, I will see that that turns into $31 for every 1 hour. And then for 3 hours, the information in my chart says it is $87 for 3 hours. And again, I can find my unit rate or reduce my fraction or my ratio, whatever you want to call it, by taking numerator, 87, divided by denominator, 3 hours, and I get $29 for 1 hour. Now, hopefully you guys can see that 1 hour, 37 over 1, 2 hours, 31 over 1, and 3 hours, 29 over 1, are not the same fractions. If they were proportional, all of these, 1, 2, and 3, would be the same. But because they are not, then my answer for problem number 1 is that they are not proportional. And why are they not proportional? Because the ratios do not reduce to the same fraction. I'm going to highlight this in yellow and I'm going to make it bold and big so you guys, oh no, too big. There we go. Make it bold and big so that you guys see why it is not proportional. So let's go on to problem number 2. Problem number 2 says, which situation represents a proportional relationship between the hours worked and the amount earned for Matt and Jane? Explain. So again, for these problems, we're just going to put the table into a ratio and then reduce the fractions down to see if we get essentially the same unit rate. Now I know a lot of these vocabulary words are getting kind of switched around. Most of them mean the same thing, so don't stress about that. So let's start with Matt. His first one is $12. Remember, money's number one, it goes on top, for 1 hour. That can't be reduced, so that was just 12 over 1. For his second one, he has $20 over 2 hours. Again, numerator 20 divided by 2, denominator, and we will get $10 per 1 hour. Now I know that there's another number in that chart. However, I can already see that $12 an hour and $10 an hour is not the same thing. So that is not proportional. It has got to be the same thing. Let's make this big so you guys see it. Not proportional. Now on the other side, we have Jane. Jane makes $12 in 1 hour, which is already a unit rate. Her next one says $24 in 2 hours. I know that I can reduce this. Numerator 24 divided by denominator 2 gives me a rate of $12 for 1 hour. And her third one is $36 for 3 hours. Numerator 36 divided by 3 gives me $12 per 1 hour. 12 over 1, 12 over 1, 12 over 1. Success! We love this. This is exactly what we want. This is proportional. Yay, Jane. make this really big. Oh no, I didn't make my smiley really big. Here. Too big, too big. Sorry for all the clicking, guys. All right, not proportional. So we're gonna go to our last one. And this one just says, explain what makes two quantities proportional. So let's go back and look at example 2. What was the difference between what Matt had and what Jane had? Why was his not proportional and hers was proportional? Well, Jane had 12/1 for all of her ratios, and Matt had 12/1 and 10/1 for his. So for problem 3, we can say that what makes two quantities proportional? Two quantities are proportional if all, not some, all of the ratios can be reduced to the same fraction. Matt's did not reduce all down to the same fraction. However, Jane's did, which is what made hers proportional. At this point, you should be trying problems 1, 2, 3, and 4 on page 37. We are going to be going over this in class. Have a great day.